Welcome back. In the last section, we covered queues and stacks. This is the first video of section 4, where we'll talk about the basics of graph theory by looking at trees and graphs. First, we'll cover trees. More specifically, we'll learn about binary trees, which are very specific and a powerful type of tree. Next, we'll talk about graphs and how they can be used to power a recommendation engine for our websites. Let's get started with trees and binary trees. We'll begin by looking at what a tree is and what kinds of problems we can solve using them. Next, we'll go over the supported operations of a tree. After that, we'll look at a simple implementation of a binary tree using JavaScript. Finally, we'll go over a real-world example of using binary trees for lightning-fast search. A tree is a data structure composed of a set of vertices or nodes connected by edges. Most commonly, a tree will have a special node called root, making a tree a hierarchical structure. A popular application of trees you'll certainly work with is an HTML document, where the HTML tag is the root of the tree and all other nodes are children of it. A binary tree is a special kind of directed tree that enforces the simple rule that no vertex has more than 2 children. Also, the order of each vertex is special in a binary tree. A left node's child has a lesser value than its parent, and the node to its right has a greater value. Because of these two features, we can find any node in a binary tree with very few steps, since at each step we reduced our search space in half. For example, if we have a sorted and balanced binary tree with 1 million elements, we can find any node in the tree with no more than 20 checks. The usual operations in a binary tree are add, which inserts a new node to the tree in the right place relative to its parent; remove, which deletes an element from the tree, taking along with it its entire subtree; balance, which sorts the tree so that it is optimal for searching; and find, which searches the tree for a given value in the node's data property. Note that since the algorithms required to balance and search a binary tree are quite lengthy, and since delete depends on search, note that since the algorithms required to balance and search a binary tree are quite lengthy, and since the delete operation depends on search, we will only demonstrate how to implement the add function in this section. To implement a binary tree class, we'll first create a node. This is similar to the implementation of node we've used in previous sections, but the difference here is that a node in a binary tree will have 3 attributes: the data, the left, and the right child, which will be references to subsequent nodes. The binary tree class, on the other hand, will simply hold a reference to the root node of the tree. For convenience, we're also going to keep track of the length of the tree. Adding a new node to a binary tree is actually quite easy. The only thing we need to pay attention to is to make sure that the new node is positioned in the right part of the tree. For this, we keep looking at each node down the tree until we find a leaf node where we can place the new node. As mentioned earlier, given the complexity involved in implementing some of the algorithms in a binary tree structure, we will not go through the code required to balance and search a binary tree in this section. However, let's assume that a find method has been implemented in our binary tree class. In this example, suppose that we want to keep a list of articles in memory while we do something with them at each page request. If we try to search through a list using an array, we need to search the array linearly. If there happens to be 100 elements in the array, in the worst case scenario, it will take us 100 checks before we find the article that we want, as opposed to only 6 checks if using a binary tree. What we need to do then is to create a binary tree and insert every element from the array into the tree. With the binary tree in place, we can now perform searches on it, knowing that we will find the article we're looking for very quickly. In the next video, we'll take a look at a graph which is similar to a tree. In fact, a tree is a special type of a graph. Let's find out how so.